Hello, I wanted to talk about lesson 9 today, direct variation. I find it's a little bit confusing because of some of the vocabulary that's used. And then fourth period today, I know we had a fire drill, so we didn't get through all the notes. So I wanted to make sure that we especially went over some stuff that would be helpful for you. So we projected these vocabulary words before that fire drill. But one of the big points I want you to realize here is that a direct variation is a ratio of y to x. So written as a fraction, I would write this always as y over x. And that will be important when we get to the assignment. So remember that y over x, and these are just two values. I used a lot of examples in class of the amount of water a person drinks could be y, and x could be the time outside. So as one increases, we would expect the other one to increase as well. They move in a proportional relationship to one another. So we get into these other terms here of constant variation. Is that ratio that exists between y and x? And then also the constant proportionality is just another name for that. So this y over x will be really kind of key as we go through and move on to the next thing I want you to see here. So these examples, I think I went through one in class, but really what we're seeing in here is that if the time is going up by 5 and the height is going up by 2, so this is 5 minutes and 2 inches, I would divide 2 by 5 to get 0.4. That means it's going up 0.4 inches per minute. I really want the unit rate here. Really, I'm trying to identify what's going on right there, what that point is. And I would do that by dividing any of these two numbers here. If I divide 4 by 10, I'll get 0.4. If I divide 2 by 5, I'll get 0.4. 6 by 15, I'll get 0.4. And if you realize the 2 is my y value and the time is my x value. Remember what we just said, y over x, right? Y over x. And if y is 2 and 5 is x, so it would be 2 over 5, 2 divided by 5 gives us that answer of 0.4. So there are a few more examples here. This one right here, we can see is that it's increasing, the wages is increasing by 12 every time. So again, if it's y over x, it would be 12 over 1. And then that's fully reduced. 24 over 2 would be fully reduced, would be 12 over 1. So my answer for this one would be 12 over 1 for all of those. Because all of these are a constant proportionality. So they're all going to have the same ratio. So I want to spend a few minutes. I know I haven't gone through all the examples. The notes will be uploaded so you can look at that. But I want to look at the assignment here. Don't want to show you that. Let me get back to this. So here is the assignment. And so now we have a table again. Notice that we have y and x in these first three examples. So you again are going to put y over x, and then you're actually going to put values in for those. So for problem number 1, my values would be 100 over 25, or I could use 120 over 30, or I could use 140 over 35, or I could use 140 over 60. I'm not going to write all those out, but hopefully that kind of helps you kind of see what I would use here. So that's what I would use for that. You will do the same thing on number 2. Now be careful on number 2 because we have a decimal. 0.5 would be your y over 5, but you need to reduce that down. Think about how many times 0.5 will go into 5. That should help you out to figure out what that would be. Both numbers will end up being whole numbers in your answer for this one. Remember, y over x. I think number 3 should be pretty easy based on what you're seeing in number 1. Again, write y over x. Okay. 4 and 5 are not too bad. We see that these are a direct variation. We know that they are starting from the origin and then going up at a constant rate. So really all you need to pay attention here in example number 4 is what is happening right here. It's asking how many place settings are there in each box. So we should be able to tell how many place settings there are from the information that's given. Next problem, done very, very similar to that one, so I'll skip over that one since I think you should be able to tell. Last 3 problems are dealing with unit rates here. So in the first one, $6.70 for 5 cans or $10.72 for 8 cans. Think about how we figured out unit rates. The amount of dollars per can is just one step of division. Both pieces of information should give you the same answer. So we're looking for the cost per can. This next question is a little bit more confusing because I'm not just going to need to divide 2 yards of fabric to cover 3 pillows. One of the best ways that I would understand this, and a student kind of pointed this out in class today, is that if we know there are, let me erase this is a little bit too hard to read. If there are 2 yards that will make 3 pillows, how much fabric would need to be to make 15 pillows? Well, think about there's 5 times as many pillows being made. So think about that you're going to need to have 5 times as many yards as you have here with the 2 yards shown. So hopefully that will help you out. The last one may be the most difficult of the unit rate problems, 20 pages in 45 minutes. I would try to figure out the number of pages per minute and then multiply that by 18. And that would give you the answer of how many pages can be read in the 18 minutes. Hopefully you find that helpful. I do apologize we weren't able to get through all that in class today, but I'm hoping maybe this video kind of clears up all of that. Thanks.